Hello and welcome to the What's New presentation for Vivado 2020.2 release. For this quick tech video, I will start discussing the high-level enhancements, followed by accelerating integration, simulation, and implementation. In terms of our OS support roadmap, you can see where we sit with our tools. We are extending CentOS Red Hat 7.8 support across the board. We also have CentOS Red Hat 8.2 and introducing Ubuntu 20.04 LTS support in this release. Vivado now supports Versal platforms that are available for everyone. All Vivado users today can experience the power of Versal architecture, including programmable NOC, PCI Gen 4, 58 gig transceivers, 100 gig multi-rate Ethernet cores, and DSP58 engines. For Zinc Ultra Scale Plus RF SoC, we have ZU43, 46, 47, 48, and 49 DR devices which are production ready. For any additional details, please refer UG973. To wrap up the complete tool offering in the Unified Installer, Beta Linux is now a part of Xilinx Unified Installer. Now, let's take a look at all the improvements that we have done on the IPI side under IP Integrator, IP Enhancements, and add-on for MATLAB and Simulink. Under collaborative design features for IPI, this time we are introducing block design container. This feature enables you to instantiate one block design inside another. The primary applications include duplication of logic or creating design partitioning or variants of the design. The key here is that all the functionalities achieved is without compromising the support for block automation and connection automation, parameter propagation, addressing, and of course, we still support various design styles. We took a big step towards improving revision control. We have significantly reduced the number of files that needs to be checked in for revision control. For both PD and IP, output products are no longer generated in the sources directory. Rather, they will be placed in a parallel directory called project.gen. Going forward, you only need to revision control the files in the sources directory. Under IP caching improvements, you can create and use read-only zipped IP caches. Addressing in IPI can be complex, nuanced, and difficult to understand. As a part of a broader effort to make addressing more easily understandable, IPI now contains the visual representation of the design address map. If you have several addressing networks in the design, there will be the same number of address maps. We also have made some improvements in the Vitus platform creation flow to make Vivado Vitus platform aware. Vivado projects can be specified as extensible platform project in the project settings and during project creation. We also have improved our GUI to manage the platform interfaces. SIPs is an integral component for any Versal design. It is required for both programmable logic-only designs and processor-based designs. For this release, we have simulation support for Versal SIPs IP. We also have OSPI, which is a new boot mode. Heterogeneous compute requires a high-performance network of connections to move data with efficiency and yet be simple and flexible. So Versal ACAP is complemented by a new network-on-chip communication network called the NOC. This communication infrastructure provides high performance and coherency support. With 2020.2, we are introducing UDM, which presents a view at higher abstraction, particularly for the AIE and NOC components, which are user-friendly. It provides an integrated view for complete Versal design that includes programmable logic, AIE, and NOC components. Some of the benefits include support for vertical constraints, support for cross-probing between various design views, and it can also show congestion and timing information. 2020.2 enables example designs available on GitHub, including some for Versal. In Vivado IDE, simply click on the tools and select Xhub Stores and select on the Example Designs tab and select the design to download. Moving on to IP enhancements in data center. With Gen 3x8 in Ultra-Scale Plus devices and Gen 4x8 in Vertex Ultra-Scale Plus VU23P device, we have expanded our device support for QDMA subsystems for PCI Express. We also have made some enhancements in Versal ACAP subsystems for PCI Express targeting GTY, PLPCI4, and CPM4 integrated blocks. Under IP enhancements for video and imaging, this time we have MIPI support for Versal. It increases the data rates up to 3200 megabits per second. On DisplayPort 1.4, we have added support for adaptive sync. We also have embedded DisplayPort option, which is general access. This time around, we have added high dynamic rate support to SDI subsystems. We have updated HDCP 2.2 support to HDCP 2.3. Under IP enhancements for wired and wireless, there is a new standalone 200 gig RSFEC for UltraScale Plus and Versal. In the UltraScale Plus 58 gig devices, this core is able to leverage the hard 50 gig KP4 FEC found in the GTM to save significant resources. We are also doing a lot of high accuracy 1588 development work. We have added 1588 support to our switchable 1 gig, 10 gig, and 25 gig Ethernet IPs. Under IP enhancements for storage, we have some new ER-NIC features with support for new VU23P device and improvements to priority flow control. NVMe Target Controller now supports the new VU23P device. We are also rolling out lossless compression IP, which deploys gzip and glib algorithms for decompression only. We will cover compression algorithms in the upcoming releases. NVMe over Fabrics reference design is now available for both U50 and Bitware 250 boards. We have some enhancements for XPMS and infrastructure and embedded. Under general IP enhancements, the key takeaways are that EFG and EMG are now available in IPI for Versal. All the wizards which are now available for Versal are listed here. Under new transceiver wizard features, full block automation now gives you the ability to do parameter passing between parent IP and GTs and makes the execution easier with the lane selections. We also have features like on-the-fly reconfiguration and code sharing and new transceiver bridge IP for Versal. Under unification of Model Composer and System Generator, install both Model Composer and System Generator for use in one MATLAB session. Users will get the option to install add-on for MATLAB and Simulink in the unified installer. For this release, users can select the Model Composer and System Generator or System Generator alone. Please note, this would be the last release allowing installation of standalone System Generator. Let's cover simulation and hardware debug under accelerating verification section. Under simulation enhancements, this time we have VHDL 2008 support for simulation. What this means is, we now support synthesizable subset for VHDL 2008. This includes shift operators, mixing array and scalar logic operators, case generate, and extensions to locally static and globally static expressions. We also have support for cross-language hierarchical name. For Versal, apart from the Xilinx simulator support, we have third-party simulator support such as Cadence Xcelium and Mentor Graphics Questa Sim. Under the hardware debug side of things, one of the new features this time around is that we have added support for selecting Ultra RAM in addition to the block RAM as Access ILA tray storage. This can be helpful to ease timing in certain cases and for design with high BRAM utilization. We also have Versal PCI debugger, which gives a nice debugging interface to read out the LTSSM state machine status. We can now handle unknown state encoding and flag illegal state encoding. With the ability to reset and refresh PCI core, you can now capture a new trace or reload the trace memory. Moving on to accelerating implementation. This time around, we are introducing Vitis HLS for Vivado hardware flows. It completely replaces Vivado HLS for Vivado, and if you were creating a C-based IP blocks for IP Integrator, it will now be done with Vitus HLS. To ease the transition, we have put together a migration guide UG 1391. In this new Vitus HLS, we have included new GitHub examples available within the tool. And then we have updated the data flow viewer. We have then simplified the tool icon layout and allowed creating and opening GUI projects directly through Tickle. Last but not the least, we are introducing a new vector type library for SIMD computations. Under RTL synthesis section with 2020.2, we are adding string support for system Verilog. Built-in string methods are supported for constant string variables. There are a couple of rules to be aware of though. Strings must be used as parameter or local parameters where the size of the string is fixed, and strings cannot be used in logic. Support has also been added for IEEE fixed point and floating point packages of VHDL 2008. With this release, you can target both the packages just by using library statements within VHDL 2008. In 2020.1, we gave the ability to have heterogeneous RAM structures. This was done to have more efficient type of RAM with less wasted space. In 2020.2, you can now add pipeline registers to these mixed RAM RTL descriptions, and synthesis will automatically balance the pipeline registers taking into account the types of RAM primitives used. Logic compaction derivative for Versal. This optimization style was developed for ultrascale and ultrascale plus carry chain primitives and has been extended to the Versal look-ahead primitive. Using this directive allows more logic to be packed into the same slices, leading to reduced area compared to the default cascaded look-ahead implementation that is optimized for faster timing. Under placer replication improvements, we have equivalent driver rewire optimization. This is a PSIP optimization that reassigns connections between the replicated drivers and loads to reduce wire delay and equivalent net routing overlap. After rewiring, the drivers can be replaced to more optimal locations in the later placer steps. The main benefit is reduction in routing congestion and improvement in routing resource utilization. For replication of drivers with far apart loads, a max fan-out mode net constraint can be paired with max fan-out to control degree of replication. The max fan-out mode now supports 3 values. Power rail definitions were supported in board files in 2020.1 along with current budgeting and power analysis. In 2020.2, we have added XTC equivalent to supply missing rail definitions or override board data. In Versal, MBuffG buffers can provide a significant improved QOR as compared to the parallel BuffG. The MBuffG global buffer type is unique to Versal and reduces the global clock utilization by providing divide by 1, 2, 4, and 8 factors while using just a single global clock resource. Vivado supports automatic transformation of parallel BuffG to MBuffG by using an off-design option or by assigning MBuffG group properties on related BuffG. We have also improved the overall report clarity for RQA with new flow guidance recommendations, compact assessment details, and ML strategy availability. For RQS, we have added new suggestions to reduce congestion near device boundaries. We also have improved the control set reduction suggestions and synthesis suggestions to improve the design performance. Under the DFX section, Abstract Shell for Ultrascale Plus devices is in production in 2020.2. This is an advanced technology that works on the top of dynamic function exchange and helps to drastically improve the implementation runtime of child configurations in a DFX design. For a DFX design in UltraScale Plus, after the parent implementation is complete, you can create an abstract shell for each reconfigurable partition. The main advantages of abstract shell include runtime reduction for reconfigurable module implementation, and it also enables the secure multi-user DFX design environments. Isolation design flow with DFX in one design is going production for Zinc MPSoC devices. This allows us to insert one or more isolated modules within a reconfigurable module. To summarize, Vivado 2020.2 contains a variety of new features and enhancements throughout the tool. To reiterate, the highlights include public access support for Xilinx-Versal platforms. Beta Linux is now a part of Xilinx Unified Installer. Create team-based designs using block design container. Abstract shell for dynamic function exchanges in production in 2020.2. Introduction to Vitus HLS for Vivado flows, and add-on for MATLAB and Simulink. For more details, please take a look at the release notes UG 973, and more importantly, you can download the latest version of Vivado at www.xilinx.com/download.